All right, everyone, welcome. In our study of business mathematics, every now and then we come across a concept it's so foundational that it really underpins entire fields of finance. We're talking everything from your own personal savings to massive corporate strategy. And today, we're going to do a deep dive into one of those concepts, the future value of annuities. Now, for any of you aspiring to a leadership role in business, I want to be clear. Mastering this isn't just some academic exercise. It's an absolute prerequisite for making sound financial decisions.
So here's our roadmap for today. We're going to build your understanding right from the ground up. First, we'll start with the core idea behind annuities, because you really need a strong conceptual foundation before we get into the nuts and bolts. Then we are going to meticulously deconstruct the formula. And I don't want you to just memorize it, I want you to see it as a beautiful representation of how financial growth actually works. After that, we'll bridge theory and practice. We'll apply this knowledge to some real-world scenarios, which is where you'll really see the light bulb go on. And finally, we'll wrap up with the key principles for success, making sure you can use this tool effectively and, just as importantly, avoid the common pitfalls. So, let's begin with that foundational idea. At its heart, an annuity embodies a really powerful financial principle. You can think of it as the financial version of running a marathon. It's not about the explosive speed of a single sprint, right? It's all about the discipline of maintaining a steady, consistent pace over a long distance. Every single regular payment you make is another step forward. And over time, all of those small, consistent steps, well, they'll carry you right to your financial finish line.
This ancient wisdom just perfectly captures the essence of an annuity. Think about it. A big financial goal, whether it's a multi-million-dollar retirement fund for a corporation or just a down payment on your first home, can seem impossibly far away. An annuity makes that journey happen by breaking it down into a series of manageable, regular steps. Those are your payments. The real magic isn't in the size of any one of those steps. It's in the relentless consistency of taking them, period after period, which allows the incredible power of compound interest to really work its wonders.
Okay, so now that we've got the why behind annuities, let's dig into the how. How do we actually quantify this power of regular payments? Well, the answer lies in the beautiful, elegant language of mathematics. We're now turning to the mathematical heart of our topic. And I want you to view this formula not as some scary string of symbols to memorize for a test, but as a beautifully logical machine. Our goal here is to understand every single component, every gear, so that we can operate this machine with total confidence and precision.
And here it is. This exact equation, in one form or another, has been a cornerstone of financial planning for literally centuries. And that's a real testament to the enduring power of compound interest. It allows us to precisely calculate the future value, that's our SN, of a series of equal payments. It completely removes all the guesswork and replaces it with mathematical certainty. So let's do this. Let's meticulously break down each and every one of these variables.
First up, SN. This is our destination. It's the answer to that critical question: if we follow this plan faithfully, what will be the total accumulated value at the very end? This number represents everything, all the principal you've paid in, plus all of the compounded interest it's earned along the way. Now, it's really important to remember that SN is a future value. It's a projection. It's a target. And the accuracy of that projection, it depends completely on the accuracy of the inputs we provide, which brings us to our next variable.
Next, we have R, the regular payment. This is the active part, the fuel for our financial engine. R could be a monthly corporate contribution to a bond sinking fund, or it could be your personal retirement savings contribution. And this is the variable that requires the most discipline. It's so easy to get excited about potential returns and interest rates, but it's the simple, consistent act of setting aside R that actually makes those returns possible in the first place. Okay, now for I. And I need your complete attention here, because this is, without a doubt, the most common source of error I see. I is the interest rate per period. I want you to think of I and R like a pair of gears in a machine. They have to mesh perfectly for the machine to work. If you have monthly payments, but you use an annual interest rate for I, those gears are going to grind, the machine will break, and your output will be completely meaningless. They must always operate on the same time frequency.
And finally, we have N. Now, just like I, N is the total number of payment periods. Let me say that again, periods, not years. A 5-year plan with monthly payments has an N of 60, not 5. So if R is the fuel for our engine and I is the power of that fuel, then N is the length of the journey. The longer the journey, the more time you're giving that compounding engine to work its magic, and believe me, the further you'll go.
Now, let's look at this specific component of the formula.
This part right here is what's truly beautiful about the math. This is actually a closed-form solution to what's called a geometric series. See, every single payment you make is a term in that series. And this factor right here elegantly sums up the future value of all those terms, with each one being compounded for a different length of time. It's an incredibly powerful piece of mathematical machinery that saves us from the ridiculously tedious task of calculating the future value of every single payment one by one and then adding them all up.
All right, we have completely disassembled the engine. We've examined every single part. Now it's time to put it back together and take it for a spin. This is where the rubber meets the road. Because, it's one thing to understand the theory, but it's something else entirely to see it in action. So let's put on our financial analyst hats for a bit and dive into some real-world case studies.
Let's start with a scenario that I'm sure is relatable for many of you. You want to save up for a down payment on a house. The goal feels huge, but your budget allows for a consistent saving of $200 every single month. You find an investment account that's offering 5% annual interest and it's compounded monthly. So the big question is, what will this savings plan actually be worth after 3 years?
To solve this, we are going to use a disciplined, systematic approach. In business mathematics, let me tell you, the process you follow is just as important as the final answer. Following a clear process like this one not only guarantees accuracy, but it also makes your work transparent and easy for others to verify. Honestly, it's the hallmark of a professional. So let's apply.
Okay, let's populate our table. R is the easy one, right? It's clearly stated, $200. Now for I and N. This is the moment where so many students go wrong. They see 5% annually and they immediately plug in 0.05 for I. But remember our rule, the gears have to mesh. Since our payments are monthly, our interest rate has to be monthly. So we take that 0.05 and we divide it by 12. Likewise, the term is 3 years, so N isn't 3, it's 3 times 12, which gives us 36 total periods.
So after we substitute those correct values into our formula and run the calculation, we arrive at $7,715.96. Now, let's pause and analyze this. You contributed $200 for 36 months. If you do the math, that's a total of $7,200 out of your own pocket. The difference, which is over $500, is pure interest. I mean, think about that for a second. You earned over $500 without lifting a finger. That is the power of compound interest. And while $500 might not seem life-changing right now, imagine this effect scaled up over a longer time horizon and with larger contributions. That is exactly how fortunes are built.
Okay, so now let's scale this concept way up. Imagine you're not saving for yourself. Imagine you are a financial manager for a corporation and you're overseeing an employee retirement fund. Suddenly, the parameters are totally different. We've got much higher contributions, a much longer time horizon, a different rate of return. The numbers are bigger, the stakes are way higher, but the underlying mathematical principle, it remains exactly the same. And that's a real testament to just how universal and powerful this formula is.
So when we run these new corporate variables through our formula, the future value after just 10 years is nearly $216,000. Now, as a financial manager, this is not just a number on a spreadsheet. No way. This is a promise you've made to your employees. It's a measure of your company's financial health. It's a critical input for all of your long-term strategic planning. A miscalculation here could have incredibly serious consequences for the entire firm and all of its people.
We've covered a lot of ground today. But before we wrap this up, I want to leave you with one final, absolutely crucial piece of advice. This is the one thing that if you remember nothing else from this lecture, I promise you, it will save you from countless errors in your future financial calculations. Let me be as direct as I can be here. If you make the mistake you see on the left, you will get the wrong answer. It is not a matter of being close enough. It is fundamentally mathematically incorrect. The logic is flawed. The method on the right, where every single variable is expressed in monthly terms to perfectly match the monthly payment, is the only way to ensure your calculations are accurate and meaningful. There is absolutely no middle ground here.
So let's summarize. First, annuities are a powerful, real-world demonstration of how consistent contributions can generate significant wealth through the magic of compounding. Second, each variable, R, I, and N, plays a distinct and critical role in telling that financial story. Third, and this is the rule you must burn into your memory, the period for I and N must always match the frequency of your payment R. And finally, understanding this isn't just about passing an exam. It is a foundational tool for successful personal and corporate financial management for the rest of your career.
So, we've deconstructed the formula. You've seen it in action and you understand its power.
This knowledge is so much more than just a piece of theory. It's a blueprint for building capital. It's a strategic tool for planning the future. You now understand the mechanics of this incredibly powerful engine of growth. So the final question, which I'll leave with you today, is this: what future will you build with it?